Have you ever been fascinated by the mysterious and awe-inspiring phenomena of black holes? These enigmatic objects have been the subject of countless studies and scientific investigations. Yet, despite all the research that has been conducted, there are still many myths and misconceptions surrounding black holes that continue to persist. In this video, we'll be exploring the top 3 myths about black holes and distinguishing fact from fiction. Black holes suck everything in. Black holes are famous for being cosmic vacuum cleaners that suck up anything that comes too close. This perception is only partially accurate. Black holes have a powerful gravitational pull, exerting a force that pulls objects toward them. However, this pull is not necessarily strong enough to drag everything in the vicinity of a black hole directly into it. The behavior of objects near a black hole depends on several factors, such as the object's distance from the black hole, its velocity, and the mass of the black hole itself. For example, an object that is far enough away from a black hole can safely orbit it, just like a planet orbits a star. This happens because the object travels just fast enough to maintain a stable orbit around the black hole without being pulled in. In contrast, an object that gets too close to a black hole can get caught in its gravitational pull and start spiraling toward it. However, this does not necessarily mean the object will be sucked in entirely. Some things can get caught in a region called the accretion disk, which is a swirling ring of gas and other debris that orbits the black hole at high speeds. The material in the accretion disk can heat up and emit radiation, creating a bright halo around the black hole. It is worth noting that while black holes do not necessarily suck in everything in their vicinity, they can significantly impact the surrounding environment. For example, a black hole can distort the paths of nearby stars and planets, creating complex gravitational interactions that can affect the stability of a solar system. Black holes emit a tremendous amount of energy in the form of radiation, generated by the immense gravitational forces at work. This radiation can be detected by astronomers and is often used to study black holes and their behavior. Black holes are all the same. The myth that all black holes are identical suggests they all have the same characteristics and behavior. This is not at all true. Instead, there are different types of black holes, each with unique features and behaviors. Stellar black holes are the most common type, formed when a massive star runs out of fuel and collapses under its gravity. They are relatively small, ranging from a few times the Sun's mass to around 20 times the mass. Supermassive black holes, on the other hand, are much larger and can have masses ranging from millions to billions of times the Sun's mass. Thankfully, they are thought to only be located at the center of galaxies, including our own Milky Way galaxy. Primordials are a type of black hole that formed in the early universe shortly after the Big Bang. Unlike other black holes, which are formed from the collapse of massive stars, primordials formed from the extreme density and gravitational forces present during the early universe's expansion. In addition to different types of black holes, they can also have different masses and spins, affecting their behavior and characteristics. For example, the mass of a black hole is determined by the amount of matter it contains, and larger black holes have stronger gravitational pulls than smaller ones. On the other hand, the spin of a black hole is determined by its angular momentum, which is the measure of the rotation of the black hole. The spin of a black hole can affect its behavior in several ways. For example, a spinning black hole can create strong gravitational waves, which are ripples in the fabric of spacetime. This is a topic we are just starting to understand. Additionally, a spinning black hole can generate an accretion disk, a disk of hot gas and dust that surrounds the black hole and emits radiation. Black holes are dangerous to Earth. The myth that black holes are dangerous to Earth suggests that a black hole could directly threaten our planet. However, this is highly unlikely. Firstly, no known black holes are close enough to Earth to pose a significant risk. The closest known black hole is V616 Monocerotes, which is approximately 3,000 light-years away from Earth. This distance is so vast that any potential effects on Earth's environment or the solar system would be negligible. Secondly, even if a black hole enters the solar system, it is unlikely to threaten Earth directly. This is because black holes are generally relatively small and their gravitational pull weakens with distance. This means that, even if a black hole were to pass close to the solar system, it would have a minimal effect on the orbits of planets, including Earth. Lastly, the probability of a black hole directly colliding with Earth is extremely low. Space is vast and largely empty, and the chances of a black hole and Earth occupying the same space at the same time are incredibly remote. Now that we've debunked the top 3 myths about black holes, we hope you have a better understanding of these fascinating astronomical objects. Black holes are not giant vacuums. They come in a variety of sizes and types, and they pose no direct threat to Earth. As we continue to explore the mysteries of the universe, it's important to isolate fact from fiction. Thank you for watching. Join us next time as we discuss new discoveries and remarkable facts about our home in the galaxy and the universe beyond.